Well, good afternoon again, everyone. I stand between you and not quite freedom for the weekend, because we do have an exciting panel coming after this to conclude the day. But thank you for joining us. Wanted to kick it off and give a little bit of overview on persistent memory. First of all, how many people in the room are familiar with persistent memory? Okay, more than half, actually. That's fantastic. We'll see if, I'll ask you to raise your hands at the end of the session to see if you've learned something new in this session. That'll be my challenge. I guess I'll warn you, I have about 3 hours worth of content, but I'll try to keep it to 30 minutes. So, first, in terms of what I wanted to cover today on persistent memory. The first thing, the distinction between persistent memory media and the access implementation, or NVM. The programming model that SNIA has worked out, what the technical working group has on their agenda is continued work in this space. Touch a little bit on the security for persistent memory, and give you an update on some alliances and use cases that we're working on for persistent memory as well. Sound like a good agenda? All right, let's see if we can, what we can make happen in 30 minutes here on a mind transfer. So first, persistent memory. Two things. One, think of it as the media. There's persistent memory media that essentially has the qualities of being non-volatile. You can treat it, think of it as treating as a non-volatile RAM disk. That's one option of the way of implementing this, but there's that distinction between the media and the implementation. The implementation can actually have things that are called NVDIMMs, for example, that are DRAM based, but they're backed by flash today or other technologies with capacitor or battery power, and that delivers you the experience of persistent memory. Again, a non-volatile memory experience that you can utilize today. Again, it's fully in production. It's been in production for years from multiple vendors, including multiple multi-vendor interoperability demos that we have done. So, to focus today a little bit more on what SNIA does, which is the programming model itself. And I guess to give you a little bit of history on this, we first started this work back in 2012. And really in the early stages, the different views on how to implement persistent memory were so diverse that if it had continued on that path at that time, and the vendors wouldn't have come together to do this in SNIA, would have led to a multitude of different proprietary implementations that were proprietary to the particular vendor that implemented it, to the OEM, to the operating system, and you would have not had the vendor interoperability that we get to experience today. We had a first summit in January 2013 that brought the industry together to collaborate and really get our minds together around this new technology and new approach to the system architectures. And then by January 2014, 1 year later, the organization put out its first version, the 1.0 of the programming model. We are now already on version 1.3, so this programming model continues to evolve in the industry, and we continue to refine it every time we go and find new ways of improving it, new use cases, and those are some of the things that I want to touch on today. But what is the persistent memory, the NVM programming model? This is fundamentally the picture that shows you. And it's really kind of broken into a few different things that I want to make sure that everyone in this room understood, essentially. First, you see here there's an NVM DIMM. So the question fundamentally first is, okay, I have a persistent memory DIMM. I've put it in my system. How does my system actually know that that DIMM is actually a persistent memory DIMM versus just a generic DRAM DIMM that's in that slot? So there's work that was done that essentially gives that identifier to the system to identify it. Once it's been identified, essentially that notifies the operating system, and essentially an NV, just in a generic way to describe it, because it's done a little bit different in every operating system, is an NVDIMM, think of it as NVDIMM driver is loaded. And that provides a series of different options, essentially, or functions, really, to the user experience. First, you have some of the management, right? How do you manage this device now that it's actually a storage device, effectively, on your memory bus? Second, it's a use case on using it simply as a raw storage device. Think of this as when first flash memory technology drives came out, right? They had the same interface, SAS, SATA, as the traditional drives. They used the same form factor. You just now had a much faster media in there that your applications all of a sudden work that much faster. Well, with persistent memory, it's similar. You can still use it in that mode, and just your applications will be working that much faster because your underlying media is now that much closer to the CPU and generally has those new characteristics. The real fun and interesting stuff happens on the far side of the slide, really, when you go and bring awareness to your operating system about the fact that you have persistent memory available on your platform. Two different ways that, and I'll focus kind of on this exciting area, because the other one, I would say it's the cheating way of, it's all the same, it just goes faster, you don't do anything else, but you're not fully realizing the full potential of this new technology until you do get to this right-hand side. It's similar with, again, the analogy with flash technology and drives. Until we got to NVM Express, we weren't fully realizing the potential of the flash memory technology because we were still operating with an old stack that wasn't optimized for the new media. Similarly here, what you get to experience are two things. One, when you have a persistent memory-aware file system. This is, your file system itself is aware, it's able to do very fast, essentially it's still abstracting things to your application, but it's able to do it in a very fast way because it has an optimized path to the NVDIMMs. And I'm using that NVDIMM as generic. Again, we talked about you can have DRAM-based or new media-based technology that lives in there. The really cool part is where you get to your application being directly aware and having direct access, and the operating system is generally just been named and known as DAX, short for direct access, for an application in user space up here to get a direct line to the DIMMs. This is the one instruction set, right? You're not going through flushes, you're not going through any other interference essentially from the operating system for your application to access that file. You have direct control in reading and writing to that file in memory. But it's persistent now. That is the mode that brings the most value out of this technology and usage model to the industry. And that's the part that I'm excited about on how do we, as an industry, begin to educate those application developers. Think of the thousands of application developers at just the banks or other industries that write applications. that now if they become aware of this model and do write directly to it, they're able to get tremendous new performance that just wasn't possible before. So a little bit about the operating systems that support this. Again, in Windows, there is DAX support that's been shipping since 2016. In Windows Enterprise, 2016. NTFS is PM aware. There's some new APIs, and there's also PMDK support in Windows. Linux, similar. The DAX support is shipping. ext4 is PM aware. XFS is PM aware. There's also PMDK, persistent memory developer kit to spell out my acronyms, bad habits. And there's additional file systems coming as well to the Linux system that those file systems will be PM aware. For VMware, as an example, they have virtualization of the persistent memory. And again, they've publicly talked about providing direct access to applications within a virtual machine, direct access to the persistent memory. So very, very exciting opportunities in that space. This gives you just a slightly different view and just more precise on the two different modes that we talked about. One specifically that is just references NVM PM volume mode. Again, that's what I call the cheating mode, where it just gets presented as file space, storage space accessible to your application. You're not aware that you're running on persistent memory, but you're from an application perspective, but you're getting the performance benefit. The NVM PM file mode, this is what I described that was on the far side of the slide, where your application is PM aware and it's actually doing that direct mapping from the PM aware apps to the PM device directly. There's already been some demonstrations out in the industry. Again, I mentioned the fact that there are several NVDIMM vendors that today are fully in production. There's several OEMs that also support this. And you can search on that without me advertising necessarily who those vendors are, but those are readily available online, and they've presented at SNIA events and other industry events. But there's two really interesting things for you to maybe take a look at from an application perspective. What are the benefits? Why do this? And I won't go into the detail of these, but last year there were demos at SAP Sapphire, a demonstration on SAP HANA implementing persistent memory technology, and what that means for in-memory databases. If you have a failure and you have to recover for it, guess what? With persistent memory, you take care of the hardware failure that occurred, you reboot the system, your database is still in memory because it's persistent. You don't have to spend, in some cases, hours to reload a database into memory, as is the case without persistent memory support. Oracle Open World, also a great demonstration there, implementing persistent memory, showcasing the performance benefit and the usage, again, recovery being one of the easy, I would say, use cases. They're each working on many other things, which they're not yet talking publicly, but they're all exploring. I'll generically cover a little bit later some of the use cases that we see and are being worked on in the industry. The PMDK, again, this is readily and widely available. It provides a toolkit for developers to make use of this without having to write their own instruction set from scratch. They can make use of libraries that automate and simplify your development quite a bit. The PMDK that's being referenced, again, the licensing, it's extremely liberal on this and readily available. I've included in the presentation some links to those resources that you are welcome to. Again, this presentation will be posted in the next week so that you can make use of those resources as you are continuing to educate yourself and put into application and use this technology. A bit of summary on the technical working group, what we call in SNIA TWGs, and the work they are pursuing this year on persistent memory specifically. So one, security. The persistent memory hardware security threat model, it's very important to understand because all of a sudden now you have on a DIMM form factor on the memory bus, something that is persistent. So let's think about that for a second. For a traditional DIMM today, it's volatile, right? So the second you lost power to it, all the data on it was gone. You don't need to worry about necessarily the protecting data to that DIMM once it's been physically removed. When you're now talking about bringing persistence to that DIMM and the memory bus, even upon removal, whether that hardware failed or removal of it, the data that was on there is still there. So automatically we have to think about how do you protect it and secure it without having to shred, literally, physically shred the device to get rid of it and protect your information that is on it. So those are some of the things that the group is looking at. I'll cover that in a second here in a little bit more detail. Remote persistent memory is another very interesting area because now it brings whole new use cases that we can start contemplating. And again, I'll touch base on those in a couple of slides, what that brings to the mix. And of course, higher level semantics and other things as we continue to learn more as an industry and we come up with new use cases here. It's ongoing work that the technical work group is considering. Again, look forward to all of your involvement in this. Participate, provide input and suggestions. It may very well be the next use case that the entire group takes on. Of course, no work is ever perfect from the first instantiation or release, so the technical work group is continuing to update some of its original work. Some of the things that they've done and continue to look at is how you do error handling with persistent memory. So a lot without spending a half hour just on that particular topic. Encourage you to look into that again if you're one of the vendors that is looking to implement this and it's relevant to your particular implementations and work. Atomicity, again, some white papers that have been published there and some of the PM data structure libraries that already have atomicity built in. And really, at this point, just wanted to make sure I don't run out of time and actually focus on the security aspect because this is quite important to everything that we do in the industry at this point. And again, for persistent memory, we've been thinking about security from day one, and now we're refining those use cases and exposures that we can see in the process. So there are some alliances here in place as well that we have collaboration with the Trusted Computing group, which essentially SNIA documents the approaches to encryption. For example, what do you encrypt? Do you encrypt actually the device itself? So you do a persistent, an NVDIMM level encryption? Well, okay, that works for one use case. but what happens when you're in a shared environment and you have multiple virtual guests that are accessing this device? How do you manage that? How do you manage the idea of the trusted user? If I'm the trusted user that has put something on that and the hardware's fail, I've removed that DIMM, now I'm moving it to a different machine. How does the new machine on OS recognize and continue that root of trust to the particular data that I placed on that DIMM originally? These are all things that we've not had to think about before because DIMMs were not persistent. So there's one thing that we wanted to at least acknowledge and realize that even though this is a new usage model and we're bringing with persistent memory, there's certain aspects of security that do not actually change, right? In fact, many of those aspects, the administrative aspects, the key management, and the memory protection aspects, those remain the same, right? If you were using KMIP or another mechanism for managing your keys for how you encrypt either at device level, file level, or volume level, again, all the different use cases for persistent memory, you'll continue to do it the same way with using your key management mechanisms. On the first order of requirements, really, that encryption of the data at rest. So there's lots of things to contemplate here and lots of opportunities for the vendors that will be implementing this technology to provide innovation and capabilities that, of course, some of them will come at additional cost, and others will be a differentiation factor on feature set or the security features. So some of the things to think about are really the authentication, re-authentication triggers, real-time encryption mechanism. Do you actually build in onto your DIMM device an encryption assist or other hardware-based encryption mechanisms for your persistent memory DIMM? And I touched earlier on the continuity of the principal identity. That's the concept of I put data on the DIMM, it moves to a different location now. How do I tell the new system that I am the owner of that? Or on a different scenario of, think of a simplistic example, you have an employee that has put data on an encrypted portion of a DIMM. That employee is no longer with your company. How do you, as the ultimate owner of that data, irrespectively, because it was created by your employee, how do you then gain access to it and provide that secure mechanism so there is a higher root of trust where you are able to take over access for it, even in the absence of the originator of that data? Again, in terms of the protection granularity, I've jumped a little bit ahead before and mentioned you have to make some decisions. Do you protect the DIMM itself so you no longer have to shred it? Think about I guess one of the use cases on here that I could bring up is something's gone wrong with that DIMM. Now you have to return it to the manufacturer for service. It's persistent. It contains your data. How do you return that physical DIMM for warranty service without, again, physically having to shred it to protect your data? That's the protection at the device level that you would have to think about and the vendors would have to think about to enable this transaction to occur. So you can return it, it's serviced, you get another DIMM. It doesn't matter because you own the key, you blew away the key, the data is on there, but it's encrypted, and therefore it's protected anyways. So you can actually do the normal serviceability of this technology and equipment by returning it back to the vendor in a traditional support fashion. The partition and volume protection data, it's again using the what I call the cheating mode for persistent memory. And the memory mapped files, that's when you have a file system that is PM aware or your application itself is directly aware. At that point, you have to make the decisions in those applications as well that you encrypt the files and you manage the protection of the files on the PM device, again, at the application level and individual granularity of each of the files. Last but not least is achieving the isolation. So we talked about the fact that VMware, as an example, is using this using persistent memory to provide access to applications within a guest OS. Well, this potentially leads to some of the cloud use cases where you have either internal private cloud or a public cloud that is essentially shared infrastructure. You have multi-tenants on there. Some of them may be your competitor. How do you actually ensure the isolation and access mechanisms to make sure that they remain private and your security models are retained? So lots of things to contemplate here. Hopefully I'm not overwhelming you, and I'm trying to go a little bit fast to get us on track. But I will leave you with a couple more thoughts on on the use cases and a little bit more of alliance work that SNIA has kicked off this year, in fact, just in the last month and a half. So a couple of the remote persistent memory is one of the key aspects that the technical work group is putting their energy in this year. So what are some of the use cases for this that have been contemplated? One, first is a high availability use case where you're able to keep multiple copies of your data. If you think on how a cloud works, and it doesn't operate to protect your data through hardware RAID mechanisms. It does it at the software layer by just making multiple copies of that file that are remote, not all in the same machine, rack, row, data center even. So if we're going to utilize persistent memory and for it to be successful, we have to think of this model, the cloud model, because those are the big consumers of storage and the growing users of storage today. We have to think of that model as I said, where an individual machine has persistent memory locally, but then you want to be able to make remote copies of it. So if that machine goes down, even though you don't lose your data because it's persistent, you would lose access to that data until you can recover that machine. But by implementing the high availability use case, you're able to continue because you have another copy, another machine that's already running. The remote share memory use case, this is an interesting one. This is a disaggregation model of looking at how you architect your systems. And it provides that concept of being able to essentially separate your compute from your memory, or persistent memory in this case. This provides all sorts of new opportunities when you're able to do it with, essentially, you're sharing memory as a central memory pool across multiple compute units. But in that scenario, right, you have to manage the process for, as you're doing a put into the remote memory, you're essentially writing to the remote persistent memory. You have to get a completion mechanism to know that, yes, that's been completed and written, before you allow essentially another user to do a get and start the read process, and that new user then has access and is writing to that particular file. On the remote access for high availability, there is a white paper that the technical work group has already published. There's the link for that. It essentially explores the requirements for consistent data recovery and the efficient remote optimization flushes Yes, it works today, but there's all sorts of things that we can do to make it faster. How do you actually reduce the latencies between the confirmed completions, et cetera, to make this process and experience be extremely fast and as seamless as possible to the application. The medias that we're talking about are extremely, extremely fast. So even the smallest amount of latency becomes visible to the application when the memory is remote versus when it's local. So there's a lot of optimization work that has been done already and that needs to be done further. So towards this, we announced about a month and a half ago a new alliance, a strategic alliance between SNIA and the OPENFABRICS Alliance, which looks exactly at exploring these use cases further, trying to identify new use cases as well for persistent memory, and trying to focus again on those use cases that are of most value. Again, we talked at the beginning of the presentation, some of the first obvious use case for PM was really latency-sensitive applications, databases, in-memory databases, logs, transaction logs for databases or applications. Those were very obvious, but there's many, many, many more use cases, some that we've not yet discovered or thought about that will come out of this. Think of, for example, for security. If you're able to do real-time monitoring of network traffic data or other things because you're able to monitor and manage that in memory, it brings a whole new opportunity for security companies in applications and services that they can bring to market that just couldn't be done before because of the technologies that were previously available. So with the OPENFABRICS Alliance, essentially what agreement we put in place is that we will work together on developing the use cases. SNIA will take on and create and document those programming models. We have the most expertise in this space. And based on those, we will feed them in and actually create user-driven, so real-world beneficial use case, but user-driven APIs, because SNIA doesn't write APIs. That's not the business that we're in. But OPENFABRICS Alliance does. That is one of their fortes. So we are having this collaboration to where they will do that work. They will do it in an open source way with the respective frameworks and APIs and bring that forward to the industry in terms of the vendors that are developing the hardware and software solutions of tomorrow. I will stop there, and I think it sounds like there's a few minutes for questions, answers. Again, I know I went fast through some of this content. Once a year in January, we have a Persistent Memory Summit in San Jose. We spent an entire day, morning till evening, focusing on just the latest updates and developments in this space. I've tried to give you a summary of the work that SNIA is doing in this space in about 30 minutes or less. And hopefully I've been able to bring some awareness and you learned something new. Any questions? Well, excellent. Thank you.